Recently, Elon Musk has made a series of important announcements surrounding Tesla's long-anticipated Robotaxi program. According to Musk, Tesla's autonomous ride-hailing system is already operating without human supervision on selected routes, navigating real streets and traffic conditions on its own. While that sounds like a major milestone, many observers, including us, were hesitant to focus too heavily on the Cybercab at this stage. The reason is simple. Despite the headlines, the vehicle is still in a testing phase and is nowhere near operating at large scale. Mass production has been discussed for months, with earlier expectations pointing toward an April start. But recent comments from Musk suggest that the reality will be far more complicated. A more serious issue has now come into view. Elon Musk has confirmed that mass production of the Tesla Cybercab will move extremely slowly in its early stages. This single statement has wide-ranging implications. It signals that the rollout timeline may be pushed back even further than many people originally expected. For a company known for ambitious timelines and bold promises, the phrase agonizingly slow immediately caught attention across the EV and tech communities. Many analysts and Tesla followers believe this slow ramp is directly connected to the radical design changes we've seen with the Cybercab. This is precisely why the Cybercab deserves a deeper look right now. The real story is not just about delays or timelines, but about why Tesla is choosing this path in the first place. Is this slow start ultimately going to benefit users? Or will it put Tesla at a disadvantage as competitors race ahead with more conventional autonomous vehicles? When Musk says that early production of the Cybercab will be agonizingly slow, longtime Tesla observers hear echoes of the past. It brings back memories of the Model 3 production hell, when Tesla struggled to scale manufacturing fast enough to meet demand. Others recall the early days of the Cybertruck, marked by delays, design revisions, and manufacturing challenges that stretched far beyond initial expectations. To some, this language sounds like another warning sign, another ambitious project facing the harsh realities of production. However, there is a second part to Musk's statement that often gets overlooked. He has emphasized that this slow pace applies only to the very beginning. Once production stabilizes and the process finds its rhythm, Tesla expects the ramp-up to accelerate dramatically. According to Musk, this is not a sign of failure, but a predictable phase in the life cycle of a completely new product. Some Tesla watchers, including well-known commentator Sawyer Merritt, have expressed confidence in this timeline, arguing that Tesla has repeatedly demonstrated its ability to move from chaos to efficiency once the fundamentals are in place. Musk has long explained that manufacturing growth follows an S-curve. In the early phase, output is slow and progress appears painful. This is not because something is broken, but because everything is new. Processes have to be invented. Machinery must be fine-tuned, and workers need time to adapt. As systems mature, output begins to climb rapidly, often faster than outsiders expect. Eventually, growth levels off again as production reaches its natural limits. The key challenge with the Cybercab is that almost nothing about it is familiar. The fewer parts, processes, and designs a factory can reuse, the slower the initial ramp must be. In Tesla's case, the Cybercab shares very little with existing vehicles. This is not a modified Model Y or a simplified version of an existing sedan repurposed for ride-hailing. It is a clean-sheet design built from the ground up for one purpose only: fully autonomous transportation. There is no steering wheel. There are no pedals. There's no traditional driver interface. This alone places the Cybercab in a category that no mass-produced vehicle has ever occupied. From a regulatory perspective, from a manufacturing standpoint, and from an operational standpoint, Tesla is moving into territory where there is no established playbook. Every assumption that normally guides vehicle production has to be re-examined. For generations, the auto industry, especially in Detroit, perfected the art of incremental improvement. New models were built on old platforms, familiar engines, were refined year after year. Changes were evolutionary, not revolutionary. Tesla's approach with the Cybercab is the opposite. Instead of adapting an existing vehicle and slowly removing the driver, Tesla is designing a vehicle that never had a driver to begin with. To traditional automakers, this may seem unnecessarily risky. Why not take a proven platform and adapt it gradually? Why not keep a steering wheel and pedals as a backup? Why not ease regulators and consumers into the idea of autonomy rather than forcing a radical shift all at once? The answer, according to Tesla's long-term strategy, comes down to cost. Cost determines everything that follows. Tesla's robotaxi vision only works if the vehicle can be produced cheaply. In massive volumes and operated with minimal human involvement, a vehicle designed around a human driver carries inherent inefficiencies. Steering systems, pedals, dashboards, and driver-focused ergonomics all add complexity, cost, and weight. Removing these elements from the design allows Tesla to rethink the entire structure of the vehicle. By eliminating the driver, Tesla can simplify manufacturing, reduce parts count, and optimize the interior purely for passengers. Over time, this could result in a vehicle that is significantly cheaper to build and maintain than any adapted human-driven car. But achieving this requires reinventing not just the car, but the factory that builds it. This is where the slow production ramp becomes a requirement rather than a problem. Tesla is not just building a new vehicle, it is building a new production system alongside it. New casting techniques, new assembly methods, and new software-driven manufacturing processes all have to work together seamlessly. Early mistakes are inevitable, and rushing this phase could create long-term inefficiencies that are far more costly to fix later. Regulation adds another layer of complexity. A vehicle without a steering wheel or pedals challenges existing safety standards that were written with human drivers in mind. Even if the technology works flawlessly, Tesla still has to navigate a patchwork of regulations across different regions. This means extensive testing, validation, and likely negotiations with regulators who are themselves navigating uncharted territory. Operationally, a fully autonomous robotaxi fleet introduces challenges beyond manufacturing. Fleet management, remote monitoring, software updates, maintenance scheduling, and customer experience all have to be reimagined. Tesla is effectively building a transportation service, not just selling a car. That shift requires infrastructure, software, and operational expertise that takes time to develop. For users, the question is whether this slow start will ultimately pay off. In the short term, it almost certainly means fewer vehicles on the road and limited availability. Early access may be restricted to specific cities or routes, and expansion will likely be cautious. This could frustrate those eager to see robotaxis deployed at scale as soon as possible. In the long term, however, the potential benefits are substantial. If Tesla succeeds, the Cybercab could deliver rides at a fraction of the cost of traditional ride-hailing services. Without drivers, operating expenses drop dramatically. With a purpose-built design, maintenance could be simpler and more predictable. Over time, this could make autonomous transportation more affordable and more accessible than ever before. There is also a strategic advantage in committing fully to autonomy rather than hedging with hybrid solutions. By designing the Cybercab specifically for driverless operation, Tesla avoids compromises that could limit performance or scalability later. While this increases risk in the short term, it could create a significant moat if Tesla's approach proves successful. Of course, success is not guaranteed. Technical challenges, regulatory pushback, and public perception all pose real risks. A single high-profile failure could slow adoption and invite stricter oversight. Competitors are also advancing, often taking more conservative approaches that may reach market sooner, even if they lack Tesla's long-term efficiency. Still, Tesla has a track record of betting big and pushing through painful early phases to reach scale. The Model 3 struggled mightily in its early days, but it eventually became one of the best-selling electric vehicles in the world. The Cybertruck faced skepticism and delays, yet it represents a bold rethinking of what a pickup truck can be. The Cybercab fits squarely into this pattern. The slow start is not a retreat, but a deliberate choice driven by the complexity and ambition of the project. Tesla is attempting something no automaker has done before at scale, and that reality makes speed in the early stages not just difficult, but undesirable. In the end, the real story behind the Cybercab is not about delay, but about intention. Tesla is prioritizing a foundation that can support massive scale over quick wins that might limit future growth. Whether this gamble pays off will depend on execution, regulation, and public trust. For now, the slow pace is a signal that Tesla understands just how high the stakes are and how much needs to be done to get this right.